Use slope-intercept form to sketch a graph of 3x minus y equals negative 6. In this case, the equation isn't yet in slope-intercept form because y isn't isolated on one side of the equation, so we're going to have to start by getting y alone. We have 3x minus y equals negative 6. We need to get the y alone, so we have to subtract 3x on both sides. That leaves us with minus y on the left. That y was being subtracted, so we have to keep that in the equation. And then on the right, we have negative 6 minus 3x. To get rid of the negative sign in front of the y, we divide by negative 1. So of course we have to divide all of the terms by negative 1. That gives us a positive y on the left. On the right, negative divided by a negative is a positive, so negative 6 over negative 1 is positive 6. The other term is also positive, so we have 6 plus 3x. Technically, the x term should come first, so if we really want it to fit slope-intercept form, we'll put the 3x first and the 6 after. But either way, we can figure out what the slope and the intercept are from here. The slope is the coefficient on the x. In either case, that's 3. And we can make it a fraction by putting it over 1. And then the y-intercept is the constant term, in this case 6. Once we have the slope and the y-intercept, we can sketch our graph. We start with the y-intercept, which is 6. So we find 6 on the y-axis. And then the slope is 3 over 1. So we rise up 3 and we run 1 to the right. And this already takes us to the edge, or even past the edge of the graph. So instead of getting more points in that direction, instead of going up 3 and to the right 1, we're going to want to go down 3 and to the left 1. So that gives us a point here. We can do it again, down 3 to the left 1. That gives us another point. We can keep going, down 3 and to the left 1. That gives us another point. Down 3 to the left 1. That gives us another point. And then once we have several points, we can connect them with a straight line and label our line 3x minus y equals negative 6. And we're good to go.